Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Hey, everyone.
Hey, hello, everyone. So are we on? Shall we get started?
Yes.
Okay, let's get going. Hi, everyone, and welcome to our session, The Art of AI Embodiment, or how to build real-time interactive experiences with Azure OpenAI GPT-4o real-time and 3D avatars. I'm Cedric Vidal, Principal AI Advocate at Microsoft, and I'm thrilled to be co-presenting today with April Spite. April, can you present yourself?
Hey, everyone. I'm April Spate. Nice to meet you all. I'm super excited for this session because it's given me a chance to dig back into my roots with doing things in 3D. So we got some cool stuff to show you. Thank you, Cedric, for letting me tag along today. I think we can go ahead and get started.
Yeah, of course. I'm very excited to do that with you today. So in this talk, we're going to explore what it takes to bring AI agents to life beyond just text and voice and into full expressive interactive beings using the latest real-time capabilities in OpenAI GPT-4o combined with 3D avatars in immersive environments. Whether you're building for the physical world or virtual spaces, will show how AI embodiment unlocks more engaging interactions and will highlight practical steps, tech stacks, and challenges along the way. Let's dive in. But first, let's take a moment to talk about where we are today with agentic systems. We are seeing a seismic shift in the way software is being conceptualized. As Satya Nadella recently said, agents will replace all software. That's not just a bold statement, it's a clear signal of the direction Microsoft and the broader industry are heading. You may have also heard the provocative phrase, SaaS is dead. While that may sound extreme, it captures the idea that traditional applications, those that are static, form-based, and manually operated, are quickly being eclipsed by intelligent, goal-driven agents that understand context, carry out complex tasks, and adapt in real time. Agentic systems are evolving rapidly thanks to breakthrough in generative AI, multimodal reasoning, and real-time inference. These aren't science fiction anymore. They're powering workflows, customer interactions, and creative tools across industries. But they have limitations. Let's talk about those. As you can see in this example, today's agents are primarily chat-based. Oh, am I on the right slide? Yes, chat-based. While powerful, this interface has some fundamental constraints that hold back more human-like interactions. First, there's a lack of nonverbal communication. Text alone can't convey body language, facial expressions, or gestures, the subtle cues that make conversations feel natural. This makes interactions less intuitive and engaging. Second, emotional expression is limited. Without tone of voice or facial feedback, it's hard for a chat agent to show empathy or personality. Responses can feel flat or robotic, even if the content is helpful. Third, they struggle with contextual understanding. Without visual or behavioral cues from the user, it's harder for the AI to pick up tone, mood, or intent, leading to misinterpretations. And finally, engagement suffers. Text-only agents can feel impersonal, especially in emotionally charged or socially rich scenarios. So detachment limits trust and user satisfaction. Today, we'll explore how virtual embodiment can significantly enhance AI agents, bringing them closer to human-like interactions. Enhanced human-AI interaction, virtual embodiments allows AI agents to communicate not just through words, but through non-verbal cues like gestures and facial expressions. This makes the interaction more natural and engaging for the user, much like conversing with another human. Multimodal engagement. One of the key benefits of embodiment is the ability to combine voice, gesture, and visual signals. This multimodal communication mirrors human interaction, helping the AI agent respond in a way that feels more intuitive, responsive, and personalized. Contextual awareness. With a virtual embodiment, AI agents gain the ability to process and react to environmental context, whether it's adjusting their responses based on the user's actions or the surrounding environment. This adds a layer of sophistication that can make AI more effective, particularly in dynamic or complex settings. Improved user trust and engagement. An embodied AI feels more like a companion than a mere tool, which increases trust and engagement, whether in customer service or educational settings. Users are more likely to connect with and rely on AI that feels familiar and responsive. In conclusion, adding virtual embodiment to AI agents brings more human-like interaction, improves user engagement, and opens up new possibilities. Let's get in the crux of it now. Now that we've seen the current state of agents, their limitations, and how embodiment can help tackle those challenges, let's see what a possible architecture of a possible integration of AI and a 3D body can look like. So the first part of this session, I will present a web-based architecture made of 3 tiers. The most important part is on the Azure AI side with the Azure OpenAI GPT-4o real-time API. That API is the component that will allow us to carry at the simultaneously a large language model with speech and image recognition abilities. Because of the fact that this is a special version of GPT-4o, which can handle more than just text, it can handle voice. The way you interact with that system is uses a different API and a different paradigm than normal text-only based APIs. In this instance, we need to capture frames of sound and send it as a stream in real time to the server and get the voice of the AI in return. And all of this is mixed with textual information. So in order to handle all that logic of communication between the client and the Azure OpenAI real-time API, we use a class called the RT middle tier. And then we connect on the front-end side an RT client. So the RT middle tier here is coded in Python, and the RT client is coded in TypeScript. So this is the base layer, the minimum layer to connect the client to the backend, to the GPT-4o real-time API, to get features such as speech and real-time communication. Then, in addition to that, in order to connect it to ground it to data, we could, oh yeah, I forgot. In order to capture the sound and play the audio coming back from the AI, we connect the RT client to the browser's mic and microphone. Then, in order to add capabilities to our AI, to ground it into documents, we use Azure AI Search to store and index documents and search for them. So for that, we use a RAG tool. I'm not going to get too much into RAG because it's a well-known pattern at this point, and there have been plenty of sessions talking specifically about it. But here, in order to ground our avatar, our 3D AI avatar into knowledge, we used the very well-known RAG pattern with a RAG tool. The interesting thing here is that the RAG tool is integrated at the backend level with the RT middle tier. But then, in order to give it life, to connect it with a 3D avatar representation to make it more lifelike, we use two frameworks, 3.js and the Ready Player Me platform. The first one to do the 3D rendering, and the second one to create the avatar and create a model out of it that we are going to load into 3.js. Then we are connecting the AI to that 3D avatar representation using a tool, which is called here an animation tool. And what's interesting here is that, as you can see, we are mixing tools integrated at the server side and at the client side, on the client side. So this is the overall architecture of the project. Now I'm going to show to you a demo of that project and show to you how it works. So let me switch to my browser here. So this is a GitHub repository. The link is going to be shared at the end of the session for you to go look at it. Here I have, let me refresh the page. And so I have the application opened in my browser. I have VS Code, and let me zoom in a bit so that you can see the code better. So here's the code of that project. The project is fully, so the GitHub repository, as I mentioned, is here, but the application is fully automated, following LLMOps and DevOps principles, using AZD, the Azure Development CLI, so you can use AZD to deploy that application to Azure Cloud with just one command. So it's very convenient, easy to do. So it's made of, like we said before, a backend and a front end. Plus what's in Azure AI, which is provisioned using AZD. Let's start with the front-end side of things. So the main class here, if we go to app.tsx, the important part here, let's move on. So we have the app here. We have the tools that I'm going to come back to it. We have the avatar, which is somewhere here. So the avatar canvas here, that's the part that allows to display the avatar here. I realized that before I delve into the code, actually, let me backtrack for a second and show you the avatar in action and show you how it works. So I'm going to click on the button here, which is going to activate the mic and allow me to start speaking with the AI. So let's get going. Hopefully it works. Demo effect. Oh, and of course I click on the button and it doesn't work. Okay, let me refresh the page. Oh, wow, okay. Do we have a problem here? Hide. Let me restart the server. I started a while ago, maybe. Okay. Let me restart the client. Okay. Oh my, okay. Do we have a browser issue? Let me try with damn. What's going on? Okay, that was working just before. Do I have an issue with the recording software? It's possible. Let me try with my other browser. Let me see if it works better with that browser. Hello. Okay, I'm relieved. So it works. I must have some kind of a problem with the mic in Edge. Okay, here we go. So we're gonna do the demo with my personal browser. It's okay. That means that we have a bunch of things here in the way, but it's okay. So as I was saying, let me do a demo of the avatar. So let me click on the record button, which is going to activate the mic. Here we go. Hello. Oh, do I have another technical issue with Hey, hello, how are you doing? Hey, hello, how are you doing? Okay, let me try again. We may have a problem with the recording software. I'm not sure. Okay, I have some technical difficulties. What can we do? Shall I show you the code first, or April, should you?
What I would suggest doing is go ahead and take us through the code itself. And then from there, once we get over to my demo, that one should be able to play. So that way folks can get an idea of what something like this looks like in action.
Yeah, and maybe while you present your presentation, I can fix the demo on my side.
No problem.
Okay, let's do that. Let's do that. Obviously, the demo gods, something's not working. Okay, so let me go back to the code. As I was saying, we have the canvas here. So the canvas is what draws the 3D avatar in the browser here. It's a 3GS canvas, and it uses the React Fiber library here, which is an awesome library which integrates 3GS in React. I don't know for those who've been tried before to use 3GS. Personally, the programmatic approach of 3GS I find very disturbing. I find it very complicated to use. The declarative, a React style declarative approach is, in my opinion, way easier to understand, because you just declare the components, and it makes sense. You just say, oh, I want an orbit control. Oh, I want a light, an ambient light, or the avatar itself, and you just compose the different.
I think you might be on mute, Cedric. All right, I am up and I am ready. Hopefully Cedric will rejoin us shortly. So I'm going to pick up where Cedric has left off, everyone. So thank you for your patience. We all know how streaming can get. So what Cedric was showing us is a demo of the avatar that he created. And the one that he created, there were some limitations to it. When we get a chance to see what it's like when it plays, essentially his avatar animates it moves around, as we saw. And although we do get a response back from the model, we don't have any mouth movement. We also don't have any facial expressions that are happening. We do have that animation that keeps playing. That animation was added to the avatar through Mixamo. I'm not sure if anyone here is familiar with that, but it is a platform that's really great for finding animations. And that animation is pretty much the avatar's idle animation. But anytime we get any response back, we don't necessarily have any mouth movement. So to start with, you think he just realized it? Oh, so to start, we'll give him some more time so that way he can get back to his part. But with that said, GPT-4o real time is currently in preview. So this isn't something that we'd recommend putting into production right now. So if you are building something that uses this, just do keep that in mind. Also, the technology is not yet production ready for widespread use, which is what I just shared. That lack of lip syncing is going to impact just how realistic the conversation sounds. We also don't have any of the facial expressions either. And so it's a little challenging to have that emotional engagement that we're going to get from the avatar that Cedric shared. And then also there is some constraints with respect to interactivity. So there's more that we can do here with that. Now, with that said, that provides us with new possibilities. And a lot of this is going to come down to just how, either how much experience you have in this space or how much you're willing to actually learn. And that is the experience that I got to have a couple of weeks ago when Cedric had reached out to me to see if there was anything that I can add to the avatar. So for some context, I've been doing Unity development since 2020, but I've been doing it on and off. So there's some things I know how to do in Unity, as well as Blender when it comes to doing things with models, but there's also some things I had to learn on the fly as well. So for this portion of the session, I'm going to share with you things that I've learned when I created my version of the avatar, while also taking you through some different design considerations to keep in mind if you decide to pursue something like this. So we have this opportunity to unlock new possibilities. I've categorized three different areas where you can add more to an avatar, and like the ones that Cedric and I are sharing today. From an animation perspective, what you would want to consider adding is that lip syncing that I mentioned before, some facial expressions as well, blinking animations, eyebrow movement, any sort of head nods or tilts as well. That's going to make things seem a bit more lifelike in nature. In terms of interactivity, there's actually some really cool things that, and examples I came across when I was thinking of other ways that we can add some more like coolness. So gaze tracking. If you happen to enable any sort of vision with an avatar like this, let's say there's a camera that's added with this, your avatar could, in theory, look and move with the movement of your own like head, for example, like your eyes, for example. So you can do things like that. You can add gestures, you have your idle animations. Username recognition would be pretty cool as well to add. And then any sort of like emotion mirroring. So let's say I'm having a conversation with the avatar. We have vision enabled. I'm talking and my face looks what appears to be sad. Well, rather than the avatar continuing to smile at me, looking really happy, it could mirror that I look sad, and then it could trigger its sad facial expression, if you will. So that's what emotion mirroring could be. Environmental reactions. This one's also pretty cool as well. Let's say that we have the avatar loaded somewhere like on my phone, and I'm walking about Los Angeles, which is where I live, and all of a sudden it starts raining. Well, if we prepare the logic to for the avatar to understand the current weather conditions, for example, I might pull the avatar up and all of a sudden it's changed its outfit to like a raincoat. That really all boils down to how you set up your logic for your avatar. So those are some other cool things that you can add. Then we have a communication side of things. So that conversational memory, we see a lot of this already when we're using various different AI assistants, whether it's ChatGPT or Copilot or like Claude or Perplexity. You know, pick one, we have that conversational memory. So if your avatar could also do that, that would be pretty awesome. tone of voice selection as well. So maybe you want your avatar to be a little more exciting when it's talking about different things. Maybe you want a little more of a lower voice instead. Thinking animation. This one I would say is probably like a genius thing to consider adding, just giving that depending on your latency that you may experience from getting the prompt from the user and then getting the output from the model, having that thinking, like if your avatar is just standing there going something like this with his finger tapping on its head, that's really helpful for the user. So that way they don't feel like the avatar is just like broken or like something's not happening. You want to give that impression that it is actually working. So adding like a thinking animation could be pretty cool. Interruptible speech. We've seen a lot of this in demos with AI assistants that have voice capabilities, whereas the assistant, it's giving whatever audio output, but then we can interrupt it. So you can add something like that as well, because that does occur in conversations that we may have with each other. And then multiple text-to-speech voices as well, which we're going to explore in just a second when I get to my demo here. But essentially, that'll give you the ability to change the voice of your avatar. Maybe you just don't like the voice and you want to go with something else. It would be cool to be able to switch between voices. So those are some of the possibilities that we have available, plus more as well. And I see Cedric has apologized. It's okay, Cedric. We were very, very interested in what you were sharing, though, for sure. But I will say I'll give you some time to present what you were going through, those, and so that way we can all get a chance to see your demo as well. So as for the avatar that I've put together and those possibilities that I just mentioned, I took my talents over into Unity, which is where I know how to create something like this best. I did use a Ready Player Me avatar, and I added some lip sync and facial expressions. Now, I did not necessarily program everything from scratch by hand with the lip sync. I actually used a Unity extension that's called Salsa Lip Sync Suite, and I'll talk about that more in a bit. But here on the screen, I have the avatar that I created. I gave her an outfit similar to something I would wear. She has like a floral sweatshirt on, which I love flowers a lot. But let's actually take a look at the demo so we can see what this is like. And fingers crossed, I have audio. So full disclaimer before I press play here, because this was something that I was creating as a proof of concept, the prompt that's going to be submitted has been hard-coded into the script itself. The prompt, I believe, was tell me a fun fact about space. What we're going to see is actually the avatar, it's going to be the avatar actually giving us that response. Keep an eye on the mouth area because that's where we can see that lip sync has been added. So without further ado, here we go. All right, she's moving.
A fun fact about space is that there are more stars in the universe than grains of sand on all the.
Oops, sorry about that.
Scientists estimate there are around 100 billion galaxies, each containing billions or even trillions of stars, making the number truly mind-boggling.
All right, I learned in that process when I clicked my screen, it pauses the video. So hopefully you all were able to hear that. I am hoping, I'm sure if anyone in the chat says they didn't hear any audio coming from the avatar, do let me know. But this is what I was able to create in Unity in one afternoon, 4 hours of dev work and just figuring out why things or how things work. But you know, there's so much more that could be added to this. So let me move to the next slide, if PowerPoint will let me. All right. So what did it take to actually build this? Not much, believe it or not. I started off with using GPT-4o as the model, same model that Cedric used for his avatar. And then in terms of the dev platforms, Azure AI Foundry, and then also Unity as well. Now, one key difference is that I know with Cedric, he utilized, I believe, TypeScript and JavaScript. Within Unity, you're going to use C#. So that's one key difference in terms of what programming language will you need to do something like this in Unity as well. Next, we have for the animation. So there's a couple things that's happening here. Mixamo, I mentioned that earlier, where my girl's just kind of moving around awkwardly. I got that animation from Mixamo. The animation that you may have seen for Cedric, that's also animation that's come from Mixamo as well. Salsa Lip Sync Suite, that's the extension, Unity extension that I used in Unity to add in the mouth movements. I will give a disclaimer and say that it is a paid extension, so do keep that in mind. Given that I have some more projects coming up where I can use this, I invested in it, but I do want to give that heads up to folks that are interested in trying something like this out. And then in terms of audio, I actually use 11 Labs text-to-speech service. We do have similar service available with Azure. However, the reason why I went with 11 Labs is that there was a very specific voice that I wanted to use, and 11 Labs gave me access to use that for this demo. Otherwise, though, if you want to stick with using the tools that we have available with Azure, we do have within our speech services, you can do text-to-speech, you can do speech-to-text as well. And with the text-to-speech, we do have various voices that are available. If you want to get really fancy with things, you can also do some voice cloning as well. You can train something that creates a copy of your actual voice and give that voice to the avatar. Could be creepy, could be cool. I'll let you be the judge of that, but that is also an option as well. So next, we have for the avatar framework, Ready Player Me. It's the same avatars that Cedric used for his avatar as well. Could you create your own avatar from scratch? Absolutely, you can do that. Given that I was seeing just how quick I can whip up a proof of concept for this, Ready Player Me was a great choice because I was able to already have a character that had a body rig, and I had the option to just point and click and change things. So if you do decide to create your own avatar from scratch, kudos to you. I aspire to be someone like you, but just do know there are other options available for finding an avatar. So how did this all come together now that we know what the technology is that we used? So we started off on the far left, the user prompt itself, which was to tell me an interesting or fun fact about space. Then from there, we get into what could be a speech to text. So my demo doesn't show this, however, Cedric's does, whereas you can submit the prompt via voice to the avatar or to the model realistically, and you would do speech to text. Mine happens to be hard-coded, but in theory, you could do a speech to text, and you could use something like Azure AI Speech. Then from there, we're going to take that string of whatever was submitted. We're going to send it to GPT-4o. You can do some retrieval in there as well. If you're building something with RAG, you have that option to do that. But we're also going to generate that response as well from the model. Now, once we get that response back, we're going to do some text-to-speech. This is where 11 Labs comes into place in my example, whereas I take that string from the response from the model, and then I use the voice Nia Davis. If you happen to be an 11 Labs user and you're curious to know which voice I use, that's what it's called, Nia Davis. And then from there, 11 Labs is going to give me that audio clip back. It's going to save it. And then Unity takes that audio clip and they're going to play it at the same time, syncing things to the salsa lip sync setup that I have in my project. And that's where we get the mouth movement for the avatar. Now, you may have noticed her mouth movement isn't perfect. You can definitely improve it for sure, but that's how you would essentially bring it all together. For me, working in Unity, this took one C# script, and it's not as long as I thought it would actually be, but believe it or not, I got it working rather quickly, and AI actually helped me out with putting together the script itself. So let's actually take a look into Unity. So I have brought some screenshots with me to just take you through what setup entails in case you're curious as to how you can set something like this up in Unity. So starting on the left-hand side of the screen where I do have the square outline, if you will, the avatar itself, that's the avatar object. Within there, where you're going to actually find the ability to start moving things is going to be with the blend shapes. So that's something that I really wanted to make sure that I covered with you all with respect to setting this up. I personally learned about blend shapes when I was first working on this about 2 weeks ago, had no clue what they are. However, blend shapes are going to be what's required if you're doing something with salsa lip sync. Blend shapes are going to enable you to actually do those mouth movements without needing to rig the entire like facial structure of the avatar itself. Now, where would someone actually set up blend shapes? Well, you can do that in Blender, for example. However, with Ready Player Me's avatars, these are available with one caveat. When you export your avatars from Ready Player Me, they do export as an OBJ file. If you then bring that OBJ file into Unity, you're not going to get access to the blend shapes. It will need to be an FBX file. Now, how do you get it to an FBX file? You'll have to convert it, and you can do that conversion in Blender. And then once you've done that conversion, you can bring it over into Unity. And then when you go to expand the object itself, like I have here in the hierarchy on the left, you're going to see what's called Wolf 3D and then underscore and then whatever part of the avatar it is. In this case, because we're working with the facial structure and the mouth movements, it's going to be within the head. So I wanted to make sure you had that information in case you're giving this a try. Now, over on the right-hand side of the screen is where we have all those blend shapes available. And so as you move the little slider for each of these, it changes something in the avatar's face itself. And there's a variety of these that are in here. The top ones are focused more on her mouth. We have some for the brow, the eyes, the nose, what have you. It really depends on what blend shapes have been added with a pre-created avatar. But if you're creating your own from scratch, well, like the world's your oyster. You can add as many different ones as you feel are necessary for the avatar that you're creating. And you can get really creative with some of the facial expressions as well. So to give you an idea what that looks like in reality, I have here the mouth open slid to about an 81.7. I believe the highest is 100. And then I have the mouth smile open to a 75.5. So when you start combining the movements for different blend shapes, that's when you really get some really cool customizations for the facial structure and movement. So I began playing around with some of these. If you recall from the demo that I did, her mouth moves, but like her teeth are like shut, which is not what you would expect when someone's speaking. Usually our mouth fully opens and not just our lips. So in retrospect, what I should have done was also do some movement as well with like the mouth opening a little more when she's speaking. But I wanted to give you an idea of what it looks like to combine blend shapes and just some of the different expressions that you can make. So in terms of where you would go and assign different things in Unity. So within the, I'm probably pronouncing it wrong, but I think it might be Visine configuration. That's where you will go in and assign the different mouth movements per the requirements that Salsa Lip Sync has requested. And it's based on a set of different vowels, but I think one of the alphabets not a vowel, but like essentially it needs to know what is the mouth shape when the avatar says A. And what about when they go O or E? And so believe it or not, I was sitting here in front of like my camera trying to see what my mouth looks like when I say those different alphabets to try to map it with the correct blend shape from the avatar as well. But You'll set those up. Salsa only requires 6, which is what I have here. I wish I remembered the exact alphabets, but once you have that set up, you're pretty much more or less well on your way to continue configuring things. You just need to add your script to the object. The script that I have here is a chat-to-speech player script, and that's where I have all the logic for everything. All right. And then in terms of what does it look like when you do that assignment, here I have on the screen is an example of how you would go with setting that up. As you can see on the screen, there are way more settings that you can do. I just went with the default since I was brand new to doing this, and I just wanted to see it work. But now that I know how this could work in theory, I want to go back and do some manipulation to get things to be a bit more on the realistic side. All right, so some key insights, and some key learnings from me setting this up. So from a technical perspective, I did learn that blend shapes are useful for animating facial features. I mentioned the caveat about the right file format as well, and that you can modify the intensity of a mouth shape. You can actually do that programmatically if that's something that would be helpful for you. From a design perspective, one thing that I learned kind of after the fact is that the animations can play while the lip sync's doing its thing. Now that I think about it, it's probably obvious that it has the ability to do that. But at the time, I didn't realize that the animations could play at the same time that we're getting the lip sync movements. Right now, my girl just reverts to doing her T pose, which is when you're standing like a T. And so it's kind of odd to have an avatar just talk while they're standing like this. And then in addition to that, having sort of that thinking animation, also kind of to disguise the latency that I'm up against in the iteration that I've created. But there are ways to help reduce that latency as well. But having that thinking animation kind of disguises the fact that things are running a little slower. From a user experience perspective, I did mention that my prompt is hard-coded. And so what I would do is just modify that to be more like Cedric's, which he's going to play for us in just a second, because we do have a video from him showing it playing. And in addition to that, future improvements, I would add a UI similar to what you've seen with Cedric's. I'd add in that speech to text, and I'd improve the lip sync. Cedric, I'm going to hand things over to you because you have your demo ready for us, so we can all check it out. You ready?
I am ready. Wow.
Yay!
I mean, sorry, everyone. Hello, I'm back. That is, I had so many technical issues. I had to reboot my computer. So sadly, we only have 10 minutes left. So I'm not going to be able to walk you through the code as I was doing it in the background without knowing I was off. And so I'm going to play a demo of previously. How do I play? Oh, okay. Can you move? Can you move ahead like 5 seconds, please? Yeah, can you play now? Okay, so that's the same exact demo, which was working at a previous event in San Francisco at the GitHub headquarters.
Here I go, dancing for you.
Can we boost the sound? It seems a bit low.
Well, it looks like the fog machine is working overtime, so your dance moves are shrouded in mystery. I can vaguely make out some people in the background who seem to be enjoying the show.
We have two AIs talking to one another. We have Ameka, a physical robot, on the right, and we have the real-time, the avatar on the left, the virtual one on the left.
Ever thought about how mythology seeps into modern culture? It's like those ancient tales decided they weren't done being rock stars. What do you think? Still relevant or just bedtime stories?
Mythology indeed continues to influence modern culture, serving as a source of inspiration for literature, movies, and art. These ancient tales often explore universal themes of heroism, morality, and the human condition, making them relevant even today. What's your favorite mythological story?
Oh, you totally nailed it. They serve as the original scriptwriters for all our cosmic drama. They're like the original blockbuster movies, aren't they? I'm a fan of the tale of Icarus. You know, flying high on ambition.
Okay,
and then,
we can.
splat, hitting
Where are
too
we?
close to the sun. Classic reach for the stars, but don't forget your sunscreen kind of story. How about you? Got a favorite myth that tickles your fancy?
I do
Okay.
enjoy the story of Odysseus.
Let's
and his
stop.
journey
Let's
in
stop it
Greece.
now.
Clever.
And maybe we can go back to the presentation. Before we do that, let me open the slide again.
I have it up on my computer, Cedric. Do you want me to go
You
back
do?
to your slides?
Yeah, go ahead. Go ahead.
Okay.
We
And
may
which slide would you like me to go to?
maybe the slide just after the demo.
Your
Or
demo?
Yeah.
All right, 1 second.
But I believe, did you present it while I was off?
I did.
Yeah. So I'm not. So maybe let's go back to the slide that compares the two approaches.
Oh, do you want to go there then?
Yeah.
Okay, no problem. There was technically one just before this, though, Cedric, for the use cases. I can start there, or I can start at the comparison one. Let me know.
Use cases is better. Go ahead.
Okay, I am ready to show my screen. All right, you want me to start here, Cedric, or the next one?
Yeah, that one. Go ahead.
Okay, cool. So here are just some real world applications. This is really like screenshot time, just in case you are super interested in giving this a try, but you're trying to figure out where exactly could you use something like this. You can use avatars across a variety of different industries, whether it's education, retail, healthcare, entertainment, in the workplace. There's also some things you can do with social and community. You can do things like tutors, game characters, which is where I'm actually going to be using this as I continue to work on this. Also, if you're doing things with like a personal assistant, for example, if you have one that you're working with that you happen to carry around on your phone, for example. I've also seen some cool demos of folks doing things with augmented reality and virtual reality as well, which is my background. So you do have a lot of places where you can implement using something like these 3D avatars with AI. So Cedric, let us know a bit more about the two approaches that we took in comparison.
Yeah, so on the left, you have a web-based React 3JS stack, which is web first, uses TypeScript, but it's a bit more limited in terms of how sophisticated the synchronization between the three avatar and the AI is. Because when it comes to web-based, the workflow that I used involves Blender. Sadly, I didn't get the time to show to you, but in Blender, you can import the avatar from Ready Player Me and customize it and create animations. But when it comes to lip syncing, it's a bit more tricky to do, and synchronizing the lip syncing with a tool in the browser is something that I have not yet had the time to look into how to do it. But so that's the benefits is that it's very light. It's web first. The inconvenience is that it's not as rich as what you can get into Unity. And so maybe April, if you can present what's possible in Unity.
Yeah, absolutely. So for starters, we are going to have that language difference. So I'm using something like, not something like, I am using C# in Unity, as that's going to be the language that you'll be using if you're doing any Unity scripting. And Unity is a game engine. There's other engines available that you could use. You could also use like Unreal Engine as an example. If you want to do something that's actually more web-based, and I forgot to mention this to you, Cedric, Babylon.js is an option as well. I know the folks over there pretty well, so if you are exploring something with Babylon.js, do let me know. But then we also get that ability to do some real-time lip syncing as well, with the help of an extension from Unity. So that way we're not manually adding all the different animations for the lip syncing. We have an extension that can do that auto magically, I will call it. So you do have that, that little bit of added convenience, but you know what? Both approaches are great. There's no right or wrong way to go about doing this. My best recommendation is to go with what you feel most comfortable with.
Yeah, thank you. And so ideally, if time permits in the future, we might try to like fuse those two approaches and get the best of both. But that's not something that we have had the time to look into yet. And so, yeah, so we are almost at time. Maybe we can take a few questions. Oh, we have that slide. I forgot. That's true.
Oh, no.
So, yeah. So final word. Call to action. After, and that's not the last version. It doesn't have my links. Okay. So here you have all the links to get started building an AI agent and using Azure AI agent services. You have the link to the hackathon, and you have the link to April's soon to be available code. And I don't know how, maybe Askia, you can share the links, or maybe I can share my screen and share my links on my screen. I don't know what's the best. Anyway, we'll share with you guys the link to the 3 avatar demo that I presented initially somehow. And do we have time for a few questions, or we are on time?
We've got time. So if you want to share your screen to share the links, we can do that. And we've got time for questions.
Okay, so then I will open. So I have the links available on my. Do you want to share my screen?
Yeah, I'm not seeing it yet, but as soon as you put it up, I'll show it. I'll share it.
Oh, I see Pamela shared something. Okay. So are you sharing my screen? It doesn't look like it.
Yeah, I'm not seeing your screen up here to share.
Oh,
so
yeah,
if you shared it, once you disconnected it, it went away. So you'd have to reshare it.
Okay, so let me share it again. Oh my God, so many technical difficulties today. Okay, do you see it now? Okay, finally. So that's the latest version of the slide with all the links, including the code source of the GitHub of the demo that I showed at the beginning. So on the bottom right, aka.ms/AI body repo. And below April's ones. And you also have the link to the slides of this presentation at AI-body-slides on aka.ms. Now questions. Yep. How do we take questions?
I'm looking in the chat right now. There was a question earlier when you were presenting, Cedric, from Danny B. It says, can we use the same logic to create the animation offline, not real time?
So I would assume that it's possible, but the way to approach it would be quite different. You would still be able to use a web-based, a browser, and load the React 3GS fiber avatar in a scene, and programmatically ask it to play animations. So the answer is yes, you can do it offline based on a script, recorded script or recorded video. but it would be a quite different code infrastructure. Like you would not have GPT-4o real time or that kind of thing. So yes, but with significant changes.
And from what I'm seeing, that's the only question that we've received directly related to the content itself. So yeah, I think we're at a good point. Well, as Cedric shared, we do have the links here. Pamela will be updating the repository with resources as well, so do check that out. And any final words, Cedric?
No, well, hopefully, I mean, go look at the code. I'm sorry I was not able to do the demo and go through the code more than I was able to. But yeah, go look at the code and everything is there. You can deploy it, you can play with it. Feel free to ask questions in the repositories comment section or like by creating issues. And yeah, happy to be here today with you guys.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.